In this session we're going to talk about the demand function and give an overview of a lot of the content of the previous videos. Just a gentle overview. It's not a long class, but it'll sort of bring things together a bit more. We start with the demand function in symbols. To save a long verbal description of demand relationships, economists usually abbreviate these using mathematical symbols. This shouldn't be intimidating. It's just simply using shorthand. It's just a quick way to use shorthand. It may be written in that format, and this is the one we had earlier with the cursor back on the screen. Okay, we have the quantity demanded per unit of time, which is dependent upon the price per unit, the price of related goods, income, tastes, and other goods, other factors I should say. Could be the weather, could be something we haven't, something unique to the product, something we haven't generally come across. So when we consider the expression, we can see it's extremely complicated. There are many variables in there, and if it was a mathematical expression, it would be very difficult to solve, very difficult to deal with. As it is, it's more a verbal expression. We're just simply using these symbols as shorthand. However, there are too many variables there. There are too many expressions inside the brackets. So it is complicated. It's difficult to say, well, the quantity demanded per unit of time depends on all of these. Which one is it dependent upon really? Which is the big influence and which is the small influence? And it's difficult. We need to isolate the variables that we need to deal with. So we could say that the quantity demanded depends on the price per unit. Ignore everything else. Or it could be we say the quantity demanded depends on the income. Ignore everything else. Ignore the price, ignore tastes, ignore everything else. We could do that. And in fact, many times that's what we do. We even do it in our everyday lives. We make things simple. But we do this using the Latin expression Ceteris Paribus, which means everything else being equal. So we simplify it using this assumption. Using the assumption, we could say that the quantity demanded per unit of time depends on the price per unit, Ceteris Paribus. And when we write Ceteris Paribus, we're explicitly recognizing that we're holding things constant. So we're telling the world there are more variables here, but we're simply ignoring them. We've chosen to ignore the variables. In other words, we ignore the determinants of demand other than the price. That's the only thing we are interested in. This expression, the quantity demanded per unit of time depends on the price per unit. This is two dimensions. There are two variables, so two dimensions. A bit like a sheet of paper is two dimensions. Well, it's three dimensions if you allow for the thickness. But a plane surface would have two dimensions, length and breadth. Like the slide we've got on the screen in front of us right now. It's got two dimensions. So we can plot that relationship. We can plot two variables on a two-dimensional space, which looks like a demand curve. In this case, we've got a demand curve for good B. Good B, well, why not? Okay, so we've got two prices, 35 and 30, and two quantities, quantity 1 and quantity 2. And we can see as the price increases from 30 to 35, less is demanded. We call that a behavioural assumption. That's based on a behavioural assumption. We say people behave in that way because as the price goes up, we economize. We reduce our demand. If we aggregate over all the individual demand curves, then we would derive the market demand curve. let's see how that happens. Okay, here we've got two demand curves. We've got the demand curve with the cursor back on. We've got the demand curve for individual A and the demand curve for individual B. A could be me, and this could be you. So at P1, my demand will be QA. At P1, your demand could be QB. Now, if there are only two of us in the market, then at P1, our combined demand will be QA plus QB, which is over here. So that's how we get the market demand curve. We simply add the individual demand curves horizontally, and that gives us the market. Now, let's look at a movement along the curve versus a shift of the curve, which some students find difficult. First of all, a change in price will move us along the demand curve. In the diagram, a movement in the price from P1 to P2 will increase the demand from Q1 to Q2. As the price falls, more will be demanded. This represents a movement along the demand curve, so it's quite straightforward. Now let's consider a shift of the curve. If we assume that the commodity is a normal good and that income increases, then the demand curve will shift to D1, D1. What do I mean by normal good? Well, a normal good is one where as income increases, the demand increases. There is a video on that in this series, so have a look at the video on income, demand, income. In this diagram, as income increases, the demand will shift from D1 to D1, because at any particular price, because income has increased, we will now demand more. The shift of the demand curve to D1 to D1 will lead to an increase in demand from Q2 to Q3 when the price is P2. Now, that really summarizes what we need to do in this session. So these various points have been covered in previous videos, and this particular session is just meant to be an overview, a synopsis, or a brief treatment of what we've covered in previous videos. So I hope this is useful. Thanks for watching.